There's a classic Sun Microsystems interview question. You type in ls into your terminal and you hit enter. What happens? This isn't a straightforward question because you could start nearly anywhere. You could start by assuming that perhaps the file system is a network file system, so that enter actually goes over the network and tries to figure out where exactly is ls. You could start with the shell and talk about the path that you search through. Do you first check /bin? Do you check user/bin? And so on. You could go even earlier and talk about the interrupt handler. You hit enter, that does a particular thing in your keyboard. It makes two pieces of metal meet each other, causes a current to pass, and then that goes on to your OS and is handled as an interrupt. There is no limit to the complexities between the keyboard and the screen. There's so much stuff that happens, and there's so many different systems, and that to truly understand and answer a systems design question can sometimes be extremely daunting. So here is one concept that can help you sort of break this down a little bit more. I call it fractal complexity. Fractal complexity comes from fractals. Fractals have a couple of cool properties. One of them is that they're self-similar, which says basically that at any level of zoom, you'll see kind of the same thing. And more specifically, you'll see the same structure repeated further down as you did up top. So how is that possible? One, fractals are kind of cool and amazing, and it's worth learning about them for fun. But in the case of human-designed computer systems, this is partially intentional. It's because humans designed them, and they worked from very simple and similar design principles. So if you want to understand HTTP, for example, you can actually learn a lot of the struggles that the HTTP designers went through by also looking at the other protocols around that they used for inspiration, such as TCP and IP and BGP. And what you'll start to notice over time is that many of these systems have similarities and differences that are related to their level of closeness to the hardware. As you move further and further away from the hardware, you can come up with more abstract concepts and vary in your design however you want. But the important part of understanding all of this is that once you learn a few systems, you'll start to see elements of them everywhere, and that's a good thing, because then you can create a vocabulary for understanding what type of system a particular thing is. So, for example, there are loosely coupled systems and tightly coupled systems. Loosely coupled systems are very popular right now, especially with the advent of microservices. And microservice-based architecture really gives you a lot of this view of fractal complexity. A microservice architecture might have hundreds of services all running within one company. And if you zoom in and look at one particular service, it probably has 2 or 3 people building a binary for it and who are dedicated to it. And those 2 or 3 people are doing quite a lot and pulling on a lot of libraries themselves. And then we can zoom in a little further and say, okay, they're using some C libraries, some C++ libraries, and each of those is very complex as well. So how does one deal with constant and never-ending complexity? The next step is abstraction, and we'll talk about that in the next video.